Hello YouTube, this is Cooking Components again. Today I want to show you my lovely Logitech Z-5500 PC speaker system, which unfortunately doesn't sound so good anymore because when watching the last WAN show, suddenly I don't know if it is the control or the amplifier in the speakers. Something broke and I only got sound through the subwoofer but no sound on the satellite, so watching the WAN show wasn't fun when you only hear bass and not the rest of the voices. So I just decided to instantly shut the system down because I didn't want to have it break anymore. So I also didn't try it anymore, so I don't know if it was only a temporary problem or if it is a permanent problem if something is broken. So I thought this is quite an old system. I think I got it before 2007. So I didn't want to risk anything of the components. So I'll just not try it again and just take it apart and have a look on it. So I just thought I would take you with me on that journey to taking it apart and yeah, let's find out if something is broken. I would expect because of the age, but it might just have been a problem with some software related parts. So it was connected over the optical connection. So at least it wouldn't be I think it wouldn't be a software problem on side of the computer, because then I would expect the audio to fail completely and not just the high voices, because I think WAN show is only recorded in stereo, which makes sense, and there is no artificial sound going on my PC. So it would have, it was actually the display shows what is transferred. So it was only stereo sound coming from the PC. So I wouldn't expect a software issue on the PC to interfere with only having low frequencies and no high frequencies. So the only thing that could have happened is that there was a software bug in the control and it shut down the speakers or something. But yeah, mostly due to something not working quite correctly inside of the complete system. So I also skipped back in the video some seconds to see if it was a flaw in the video or not, and no, it was not a flaw in the video, not in the WAN show. So yeah, it was totally the sound system. So yeah, it's older than 2007, so it's 15 years old or something, at least 15 years old. So yeah, let's have a look, and perhaps we need to replace some components. I don't know. So from the electronic side, there are two main parts of the system. The first part is this control panel, where you can turn the system on or just turn it on from standby. You have a dial to control the volume, but with this dial you can also control the levels of the bass, of the center speaker, of the surround speakers, and various other settings. So the control panel might have a problem. It has at least one problem because the backlight of the LCD failed, and that is one thing I repaired years ago and it failed again. So maybe they have chosen a bad value for the resistor for the backlight or something, because I can imagine why else the LEDs for the backlight burn out so frequently. So I think after I changed them, they worked for a year or two, but backlight was always an issue on this device. And the second part of the electronics is contained within the subwoofer and contains the power supply for the system and the control panel, and also contains the amplifiers for the subwoofer and all the satellite speakers. So they are shoving around a lot of power, so they need two big heatsinks. So I think the best thing to do now is just start taking it apart. So let's go. Ooh, that were a lot of screws. So, will it come apart? I don't know. Doesn't look like. I need something to pry. Nope, that goes in there. Oh, it moves. Oh, nice sound. Not really. Oh, and it popped apart. Careful, where are the cables? Oh, maybe I can just lie it flat down. Oh. Less than I expected. I expected more on this side of the electronics. So just back in there you can see the transformer hiding, and behind it you can see the subwoofer speaker that is actually the front of the device, and these red and black hiding cable that's quite thin is the subwoofer cable. I'll show you that later. And by the way, no, this is not a spider's web. This is only remaining strings from the hot glue used in this device. And here you can see the power coming in, going through a fuse, through a switch, and then down into the chassis to the transformer, and coming back from the transformer are these 5 wires. 2 of them are hitting a bridge rectifier, and after that all of them are going to this main PCB, and the small cables here are actually the cables for the subwoofer. So it's I think it may be quite enough for the job, I guess. Looks a little bit small, but hey, yeah. I think these are the cables for the satellites that are going to this PCB with the back connectors. So you plug the cables for the satellites in here, and they look a lot thicker. Oh, nah, Now I got thermal grease on my fingers, so somebody had fun with the thermal grease here, and yeah, all the cables are a little bit covered in it. So yeah, looks like fun, I guess. So looking more closely into the PCB, you may be able to make out a second bridge rectifier down here hidden. So I guess this bridge rectifier is for all the electronics, control stuff, logic and so on, which might be filling up this capacitor. And the other bridge rectifier, the big one, is making 2 voltages for the amplifier. So the voltages for the amplifier are differential voltages. So the capacitors state 50 volts on them. So maybe they are generating something like a plus and minus 36 volt rails for the amplifiers. And down here you might be able to see a 78M18A voltage regulator and an 79M18A voltage regulator. So these 2 voltage regulators are creating a positive 18 volts and a negative 18 volts voltage rail, which might be used for all the operational amplifiers spread all over this PCB. So I looked around the amplifier board a lot, and I also measured these 2 capacitors, which should have 10,000 microfarads, and I measured them with 9,200 and 9,100, so that's still okay. I think they have 10 or even 20% tolerance, so that's good. I measured the smaller one here with 4,700 microfarads, and the measurement came to, I think, 4,200. So that's also good. I couldn't measure all these small caps, but they look okay. They don't have any signs of leakage or deformation, especially here on the top seals. I looked under the board. There are foil caps and one electrolytic down here, which is a non-polar 10 volt 100 microfarad capacitor. I think that one belongs to this amplifier stage on this corner. But I don't think that the capacitor down here would influence the satellite speakers, because this amplifier stage and this amplifier stage seem to be connected to the subwoofer. So they are combining their power. So the amplifier board is really tight integrated in here. So every single one of these amplifier stages is held down by this bracket to the aluminum cooler plate. And there's a lot of, I don't know how these sheets are called in English, but they are glimmer sheets. They are made of a thermal conductive but not electrically conductive material. And also there is a lot of thermal grease here, so I don't want to remove this if I don't have to. So I will try my luck with the control unit. But there's one interesting spot I found, and I will show you this now. So down in here, where the rectifier for the logic sits, down there. I think that's really disgusting. I don't know if you can see this now. Perhaps we need a little bit more light. That's more washed out than visible, but yeah, that looks disgusting. And also really brown. So I think at least heat of this rectifier degraded that glue. But on the other corner, which is behind my finger, it looks even more disgusting. Let me try to get that for you. So that is looking really evil. Ooh. Somewhere under there is a small MLCC capacitor. I hope that's not corroded away. It looks somehow... Yeah. I don't know what happened to this gunk. I don't see a chance of that rectifier leaking, so is it only heat? I don't know. But it looks really bad. Ugh. Disgusting. Hey, I found this capacitor. Beautiful. Somewhere in the dirt. So this is now a handheld shot of the PCB on its cooler mount, and I just wanted to show you the capacitors behind the PCB. So they're down there in the corner. The blue thing is a 100 microfarad 10 volt non-polar capacitor. It's the only one I could find. And then these green things here that look like they have been dipped in some green gluey-like stuff. Ignore the hot glue, that has nothing to do with these capacitors. It's only holding them in place. And I think, yeah, that might be for vibration dampening. So these green things there that look like dipped are actually some kind of a foil capacitor. So there are a lot of them, and I think they are for some audio purposes. I don't expect them to be bad, because they will be in the different amplification stages for the different speakers. So when one of these puppies blows, then I would expect one channel to fail and not all the front channels. I don't know if the back channels weren't working because I didn't have them connected. So I'll now start taking apart the control panel. I did this before, so I know a little bit where to go. I need the cable out of the way. So there are 4 screws in the corner, and there are 2 screws that hold the stand in place. Maybe I don't need... I think I'll need to take them out. The stand is in the way. That's a nice hefty metal stand. Okay, there are some plastic clips. There's a big PCB inside. Beautiful. How can I get it out of there? Oh, pushing the connector through helped. That's a sweet, shiny PCB. There are a lot of components on that PCB. So let me take a closer look. So here I got the front side of the control panel board, and man, that soldering looks rough. Can you see all that flux residue? Man, they had fun. So I noticed that there are a lot of components that have been hand soldered on this board. Even these SMD capacitors. So all the tactile switches, the infrared sensor, and these capacitors. Okay, the camera stand is in the way. But you can see all these capacitors are hand soldered. And they're even floating, so yeah, they have been hand soldered not very nicely. And everywhere that flux residue. Crazy. Even that THT diode. It has been hand soldered. There it is. And that SMD capacitor, I mean, they've soldered some component on the other side there, so maybe they just came too close to that capacitor, but hey, there's a lot of hand soldering. Not in this area. So now to the other side. This is now the back side of the PCB, where all the logic chips are. So there's an EEPROM with, I guess, firmware. A big Cyrus logic IC. I think that might be a DSP, and it's upside down. A Zylox CPU. A crystal for that Zylox CPU. And a lot of other components, but I don't see leaky caps. I only see a little bit of dust and more flux residue. But all in all, it looks good. The only discolorings you see here and on some of the capacitors are from some kind of marker. So there is yellow marker and even red marker that has been used on this PCB. I think you can see it on this IC too. And even green marker. Yeah, didn't notice that. They had fun on this PCB, but I don't see anything wrong with it. And quite honestly, I didn't expect anything to be wrong with it. Yeah, that's flux residue. And a lot of dust. So there's still this mysterious LCD display which seems to go broken on a lot of these units. Not really the LCD. I mean, after all these years, this LCD is dying too on some of these sound systems, but I've seen a lot of dead backlights. And as you see from the markings on the LCD display, I've been in here before to fix the backlight. And now it's gone bad again. So I'm here, so I can just go further and fix up these backlight LEDs. This thing that is special about this LCD is that it uses 20 characters in 2 rows and not 16 in 2 rows. Most LCDs you find on eBay will have 16 characters in 2 rows. Also, you might see that this ribbon cable only has 8 connections. So this LCD might be driven with some kind of serial protocol. So RS-232 or SPI, I don't know at the moment, might even be I2C. I really don't know, and the form factor is somehow special, so they don't have fully mounting holes, they have some kind of castellated holes. Which makes this display really hard to get if it is broken and you need to replace it. So that's why it is really beneficial to fix this display and not try to get a mostly overpriced replacement. So there are 3 LEDs on this side of the LCD and I'll try to remove them now. First one gone. Second one gone. And the third one is gone. Nice. And again for the other side. 1, 2, 3. So here I've got the used LEDs under the microscope, and you can see how burned their phosphor coating looks. I mean, these dark markings on this side are flux residue or something from the soldering process. But if I tip this LED around, you can see how dark the phosphor coating is in the spot where the LED chip is. On this one even visible. You can see that small chip and the dark spot that is surrounding it. Come, tip over. Yeah, there you can see it. Crazy. So it looks like they weren't meant for the current they got. So yeah, they died a painful death. Oh, crazy burn marks. And you might have noticed that they're missing 2. Yeah, just because I lost 2. Shit happens. But hey, there are more crazy things to come. Look at this. There's still a little bit of life left in them. Crazy how dim they are. I mean, I can give you a working one for comparison. It's not the same type, but it's close enough. Wow. That's the difference. Can I get them in series? Ooh! I can. So the LED is still conducting the full current. But it's not glowing anymore. Or not a lot. Come. So now the fun starts getting these LEDs back onto the LCD PCB again. First I'll add some fresh solder. But I think I'll do it only on one pad. So I can shove the LED between there and then add the second solder blob. So this 0802 component is clearly not the perfect fit. It's much too big, but it is what I had at hand, and even if it is a quite big SMD component, I already lost one of them. Crazy how fast you can lose SMD components. Ah. It's half in there. Okay, it's somehow in there. Not nice, but it might work. But that's ugly as hell. And now cleaning the other side before soldering new LEDs. try soldering, they said. Will be fun, they said. But it doesn't look like. But hey, at least it works. Nice. So let me just put the front panel back together and then we can return to the amplifier board and look for the fault there. Nice. So I've been digging around on the internet for a little while and the most suggestions I could find were regarding this rectifier we found earlier when taking the subwoofer apart, and this seems to be often the case that this rectifier fails. And some also suggested that the voltage regulator, which is tucked away on the heatsink, also might fail. So this rectifier, this voltage regulator, and this capacitor belong to the voltage rails for the control panel, and I think for some stuff on this board too. So if this rectifier has a problem, then that might lead to the control board crashing, because it may happen that this rectifier gets dropouts. So it is not quite dead, but sometimes starts a little bit failing. And that might also count for this voltage regulator. So I will try to get them out. And at the moment, my suspect is this rectifier, because all the stuff around it looks very burned. So this rectifier seems to get very hot, and hot components might start to do crazy stuff. So I think I'll try to change this rectifier and perhaps look for a replacement voltage regulator. At the moment I couldn't get matching capacitors, so I won't exchange them at the moment, but they also look very good. So no need to change them, but you see this construction of heatsink and how it is crammed in there, and a lot of heatsink compound, and yeah, if I'm in there, I would like to change the capacitors, but I don't have these big capacitors at the moment. Perhaps I will change some of the smaller ones, but even they look in very good condition, so I don't think that there is a need for a replacement there. So first of all, when shoving the stuff around and trying to get the board out, I might need more cable lengths. So from this side, I can't get more cable lengths, so I'll need to loosen this board too and remove it. From this side, I can just get the cables from the rectifier, and from this side, I can unplug the cables from the subwoofer speaker. I hope that I don't have to remove the transformer, because these cables are glued in place and I want to leave them there. So I'll start with this cable tie and hope that it gives me enough clearance. And for everyone wondering, there are two yellow cables, but this orange and this yellow cable go to the transformer, and this yellow cable and the black cable go to the amplifier PCB. I need to dig in deeper into the speaker. So somewhere in there are connectors that are connected to the subwoofer. And I'll try to get them now. I can see them. Okay, left one. That's easy. The right one up. I don't damage the connector on the subwoofer. I need both hands. Uh-oh. That's not good. Yeah, I have a bare wire in my hand. Okay, I'll need to fix that later. And now for the connector board. I'll need to get all the screws off. So there's a lot of glue on the screws, so they are hard to get out. There's a lot of this blue stuff, but I mean, a small idea could be just to add a small drop of oil. I don't like this trick, but maybe I then can get the screw out. Okay, the oil trick seems to help. Yeah. That screw head is done. Two more to go. they are plastic screws, so they don't have glue. So the control panel board is still stuck in there. And I think it's just the glue. So yeah, I think there's just a little bit of force needed to get it out. Careful force. Yeah, digging away the glue. Okay, maybe the connector for the control panel is screwed in there too. I mean, it doesn't look like. I mean, it looks like that this connector has a cutout, but from inspecting it a little bit closer, I can see that this kind of cutout is only stamped in, and it's not a cutout. So this connector is actually screwed to this metal plate. And if it drops through now, no, it still doesn't go. But I think it's clearly visible that there were no big holes where the screws could go through. There's only a big stamp, and inside that stamp there are smaller holes. And now for the second try, getting this board out. Yeah, this looks promising. But still the front panel connectors holding them tight. Yeah. And it's freed. And luckily nothing looks damaged. And now the question is it enough to remove all these screws to loosen up the power components from the heatsink and then slide the PCB out? Or do I need to also remove all screws of the heatsink so that I can get the heatsinks a little bit shoved to the left and right, or removed completely? I don't know. We can only find out. Yeah, and by the way, this screw and a screw back there also need to go, because they connect this the amplifier PCB to the heatsink. Yeah, and there is a hole on every heatsink side where the heatsink can connect to the PCB, but the hole is not enough to let the complete PCB go through, so it's a really complicated and annoying assembly. So I think I'll start with the easy part, or hopefully easy part, and that is removing these long screws that fasten the power components to the heatsink. That's all fun. Oh man, also these screws are glued. There's one out. I need another screwdriver. This might work, this might not work. Only one way to find out. And it worked. Beautiful. The whole bar's moving. Shit. Yeah, that's the over temperature protection. That's the first look on this side of the power stages. Just a real mess of thermal component. Yikes. Luckily, these screws are easier to get through. And the second half of power components is freed. Yay! It might get very annoying to get the screw out, so I'll let you sit in the first row. There's a lot of glue on it. A lot of glue. Oh shit. I think the rest is tying with now. Oh man. Oh, it's not tying with. I think it gave way. Yeah. Well, still, the threads look okay. Just a little mangled. And before I can slide this board out, I need to get the nut that is behind this PCB that holds the screw on the metal plate. Nice. I like this construction. Yeah, nice. Somehow I need to get this out of there. I hate this glue. Yeah, looks fun. Oh, not quite there. Yeah. Now it's out. So now I should be able to slide the PCB out. Okay, it's moving. But somehow I need to get past all these mica sheets. I hope I don't have to remove them. Maybe I can just bend the bend the power stages back a little. Okay, so some of these, so the mica sheets are overlapping and some parts of them are sticking out a little bit. So I hope I can get the IC packages past them. No, that mica sheet here is moving with us. So maybe I can just pull it out. Maybe I should pull all of them out. Oh man, that's a mess. Maybe I can let that one stay in place. And there the PCB comes out. Or not. Yeah. No, it comes out, I guess. Beautiful. So now we can take a closer look at the underside of the PCB. And there's not a lot to see here. I mean, a couple of these, I think, foil caps and a single electrolytic and some bridges. But that's it so far. The rectifier is here, and at least on the bottom side of the PCB I can't see anything that has decolored or changed. There's a little bit of flux residue, but yeah, it is what it is. And I will just start desoldering the rectifier. So it works a lot better when the soldering iron is on 350 degrees C and not on only 300 degrees C. Still, I'm not making good contact. I'm not sure if I can wick away the solder. That doesn't look very promising. Ah, that's better. Okay, that pin is free. Maybe we have a chance. There is thermal paste all over my hands. I'm giving up. Perhaps it's a better idea to just free the rectifier on the other side from the glue and then heat the pins up and trying to just rip it out. Not the nicest way, but I think we don't have a chance. Perhaps we freed it up enough the last time we were tinkering around in this area. So here's a piece of wire. I'll try to shove it under the rectifier from one side to the other, so I can use it to pull on the rectifier. Okay, maybe there's too much glue under the rectifier. Yeah, true. Nice. So maybe I can now try to heat the rectifier up and pull it out. Millimeter by millimeter. I don't think it's moving now. Can't see it exactly, but it seems to be moving millimeter by millimeter on even smaller steps. But I can see that the pins got shorter on this side. So something's moving. I think it's trying to go through. Doesn't quite there yet. Well, this is nice. But maybe the coming out. I really don't like that between two. I think I don't have any chance. Yeah, it's read. Oh man. I need to show this to you in a close-up. I mean, I didn't play very nicely with this rectifier, but it clearly looks that it not only got mangled by the soldering heat, but also spilled its guts. I don't think that... that's disgusting. I don't think that this blowhole down here originated from my soldering efforts. So, yeah, I can move the whole pin. Yeah. So, yeah, this rectifier is very dead. Can I look in more closely? So somewhere between these contacts should be diodes. But I haven't found one yet. Oh, okay, there are the diodes. Small pieces somehow put between these legs. Okay, get a new one. So here's a close-up of the spot where the rectifier lived in. And the worst part of it is that I'll need to clean that mess up. Oh man. Oh, I shouldn't damage that capacitor. Okay, that looks already damaged from my cleaning. So I might need to replace it. Okay, I think I'll do the rest off camera. So I just replaced the ceramic capacitors and the rectifier off camera because with all that tight space here between the other components and cables and the camera in the way, I just decided that this is not worth it. I mean, it's just soldering in new components, but I also cleaned this up. Not very interesting. Yeah. So I'll gunk that up later, but before that I think it would be best to test if the circuit works. And this is the other side of the rectifier part in close-up. You see the PCB is quite mangled, but I think it's still okay. Yeah, the new rectifier is soldered in place, the wires are cut, and I cleaned it up as best as I could. But you see some remnants are still there, some discoloration of the PCB and burned in flux. And I can't get that flux off the PCB. So it will stay there. Not the shiniest part of work, but hey, it might do the job. And here comes the unplanned fun part. Removing the subwoofer to get the connector back. The ripped off connector back. Oh, that are bad screws. Whoa. They look evil. What the fuck? A piece of cable tie. I think that screw hole might be not good anymore. But that could just be me playing around with this thing years ago. So this is not coming off. How does this work? I removed all screws. Okay, I remember that I once had this grill removed, so maybe I should remove this grill. And I had this grill removed for aesthetic reasons, not for fixing something. And I don't know if I glued it in place again or it is just... Yeah, it's just clamped in there. I don't need to remove this big thing. Now I remember. A nice big speaker membrane. Ooh. This feels so good. Oh, careful around here. Oh, I don't want to break the speaker. It looks like the battery of the camera is dying any second now. Perhaps I should replace it. Can I get the speaker out before it dies? How can I get the speaker out? Which parts belong to the speaker and which don't? I can't see. Oh, I can see now. Oh, there it goes. Ooh, that's a nice big speaker. I hope it's in focus. I don't think though. Now it's in focus. And it's upside down. And there you can see the ripped off connector. So with a fresh set of batteries in the camera, let me just clean this thing up a little bit. Ooh, there's a lot of dust coming off the speaker. Now to the other side. Yeah, big magnets. Nice. Does anyone know what this hole is made for? I don't know. Please leave it down in the comments and explain it to me. Can we see the coil? Or whatever's inside there? Yeah, looks crazy inside there. Oh, no, I can't just lay it down. I need to find a solution for that. So this might not be the best solution, but hey, at least I have something to protect the speaker from sitting flush on the table. Now I need to find out how I can get this connector off. Yeah. Magnets. No, doesn't look so good. Can I shove something other connector? Maybe. No. I need to now. Perhaps a more flatter screwdriver. It's already bent because I did something else with it. And that looks promising. Hey. No! Ah! This magnet. That's crazy. That's the flatter screwdriver bit. Okay. I don't have a replacement connector. And I don't have pliers to crimp them, so I think I'll solder it on somehow. Perhaps I can bend it open a little bit to get the wires back in. Oh, I don't like that. But I don't have another solution yet, so I think that's the way to go. Doesn't really look like that this is opening up again. Give me a sec. So this connector has been crimped very well. It looks really nice. And somehow still I managed to break it. I hope I can bend it open again. At least a little bit so that I can put the cable back in. and solder it in place. I mean, these connectors are made for only one use, but hey, I can try to get a second use out of it. Okay, at least that part is open. I think I'll just break my driver bit. It looks a little bit bent, but still okay. I mean the driver bit, not the connector. Yeah, it's stuck. Okay, perhaps I can get my cable back in. And this flap on the back is what locks the connector in tight, because it has this little notch, and the connector on the subwoofer has a hole, and this notch falls into the hole of the connector, and yeah, it prevents it from getting off the connector. So that's why I ripped the cable, because this connector sits in really tight. So I'll just bend it. When I was removing the connector, I just bent this outside a little bit, and now I'll bend it back in a little bit so that the connector can lock in again, hopefully. Or I'll need a new connector, or I'll solder the wires directly to the speaker, which is not a good idea. By the way, here you can see the hole on the speaker side of the connector. That is what made my life very tough. And also the little one has one. A little tiny hole. And I think now it's time to put the speaker back inside. Yeah. Oh, it's pivoting out. They have the magnet on the back and all the weight. I mean, I could put the speaker box on its back, but that wouldn't be that funny, would it? Can I hit the... Can I hit the... how's it called? Threads of the screw? Can I hit the all threads? I'm not really sure at the moment. Yeah, on that one I got the all thread. Now it feels a bit too. Oh, I'm hitting the rim of the speaker, because the speaker is not in its correct position. Yeah, I'll put some screws in before I tighten it down. And I hope I can get the connector connected from the backside, or I have to take this back out again. Don't know if these big screws really do anything. So, and as I remember, this one here gets the cable type piece. Yeah, that's clearly not sitting right. But that's a broken hole. So that's as best as I can do at the moment. So I'll try to fix this connector now. Okay, the wires. Will they slide in? Yes, they slide in. Can I get the insulation in? Not really. Okay, perhaps it's somehow in. And I just found out that I have some kind of crimping tool. I think it's a knockoff crimping tool, but it may be working. So I'll try that. And if this doesn't work, I'll try to solder it. I mean, the whole insulation will melt away, but the wires will have contact, and that's good. So, but first I'll try the crimping tool. Can you see that? Yeah, it's not fitting very well, but I'll give it a try. It's not coming out again. Oh. Maybe I should have oiled the tool or something. This gets a little crazy. Yeah, it's out. Yeah, and it just looks quite decently crimped. It's fixed in place. Yes, there's nothing to complain about. I mean, if you look closely on the back side, the connector looks an awful lot mangled, but it's working. Nice. A quick side note on the amplifier board. I looked up what these IC packages on the heatsink are. So these 7 big ICs are 100 watt amplifiers from ST. The number is TDA 7294, and these can drive up to 100 watts at plus minus 40 volts and are class AB amplifiers. And yeah, they look beefy. And for the subwoofer, there is an option. Where's the schematic? No, not this one. You can bridge 2 of these amplifiers to 1 speaker. So that's why there are 7. 5 for the satellite speakers and 2 driving the subwoofer. So there's a lot of power in this system. First, a small disclaimer. I'm working with live power now. Don't do this at home, at least not if you don't exactly know what to do. I'm not responsible if you kill yourself or hurt yourself or anything else. You do anything you do with electrical stuff on your own risk. So I just prepared a small test because I don't want to put everything back together and then notice that I have forgotten something or something isn't soldered correctly, isn't working, yada yada, whatever you can think about. So I have here power coming in. I have connected the control panel. The subwoofer is not connected, but I put the cables into separate plastic bags so they can short out, even if these amplifiers are have a short protection in them. I put the mica sheets behind the power stages again, and also behind the voltage regulator, so that they can't short out to the chassis. And I screwed the back panel back in, so at least the screw where the earth connection goes to, because I don't have this earth connection connected, because I would have to mount the whole IC package assembly again. And I didn't want to do this, but these points are connected, so it's kind of equal. I hope that is enough. No speakers connected, no subwoofer. I only want to see power go on and nothing go bang. Yeah, and I think that's it. I think I can start this test. I hope nothing blows up. I want my sound system back. Please cross your fingers. No, there's light, no smoke. Next step. There's backlight on the control panel. Control panel is reacting. Okay, I think that is enough. Ooh. Great. That looks good. So I think it is time to put this thing back together. And starting, I will add some thermal grease back to the mica sheets, in the hope that it will find its way behind the power stages. And then I'll try to slide the PCB back into position. Maybe I need to rub the thermal paste a little bit onto a good spot for every power device. Oh, now my tweezers are sticky. So, and now I'll try to move the PCB back in position. This mica sheet wants to move with, and now it's behind. So I'll need to find the screws that held the PCB in position, so I can get the PCB in position. So screws and spacers, and something to hold the PCB up. And a screwdriver. So I'll need to realign all the mica sheets with the holes behind them. Oh, that's funny. The mica sheets sometimes have two holes close to each other because on the first assembly they had pre-done holes, and when they assembled it they just punched the screw through it and made new holes. Not that great of a job. And not to forget, the temperature probe should be put here. Oh, I think it's the wrong metal bar because the holes don't align. So maybe I should try this metal bar. Oh, that's upside down. I can't reach the screws, so maybe I should take this part out again. I hope I found a replacement for the screw with the destroyed head. Somewhere in my parts bin. Maybe it is now time to plug the subwoofer back in. Hopefully I can find that connectors. Or I'll have to remove the subwoofer again, and I hope that's not necessary. Okay, I hope the cable is routed back correctly. And now I'll try to hit the connectors. That's an interesting task. So the first connector is fully seated. Now for the other one. Oops, sorry. Nice, both connectors are fully seated. And now a little bit of cable management. I hope I can find out how these cables were managed before, but I'm not sure. I think this belongs this way somehow. Yeah, looks quite good. I don't know exactly how this went. But now I have to walk around. Something I missed is the silicone to glue these pieces in position again so they can't vibrate. So I have here some kind of a non-toxic acid-free silicone. I hope it's still good. Yeah, something's coming out. And I'll try to stick the capacitors together and the capacitor down onto the rectifier and some other parts. I'll just get crazy with it. Oh. You need a lot of force on this cartridge so that something comes out. I can't see that. Okay, I can't. I'm sure later. Oh, God.
Is there something I missed?
So I hope that's enough. Or maybe not. Perhaps something between here. Okay, maybe now it's enough. Oh man, finally, I think I can start putting this monster of subwoofer back together. Oh, I hope I didn't miss something. If, then I'll need to open it up again.
Yep. Du også have to just from the PC when I turn it on. Then not nothing.
Okay, I'll wire everything up and then for the final test. I'm really tired of this project. It took a really long time. So now the final test. Will it work? Will it not work? Will it explode? I don't know, but we're here to find out. So I've got the remote control, which luckily has a test button, so it plays noise on every channel one after another. I think that's a good test. So let me turn it on. Oh, a louder noise than I expected from the transformer. It's on. Volume. Test. Wow! It works! It didn't die! Yes! Yes! Woo! Oh, that rumble's nice. Turn it off. Yeah. Wow! And the backlight is nice. Beautiful. So, I think that's all for today. Thank you for watching. Like, subscribe, thumbs up, all the good stuff. Put your comments down below. And I think I will see you in my next video. Bye!